Right, we're live now.
Awesome. Do you want to get us started?
Yeah, please, you go ahead.
Okay, great. Awesome. Thanks so much for having us today here, Siva, and thank you to all the participants of the Ur-Hackathon event. Shardeum is really excited to be sponsoring it. My name is Greg Hemmer. I'm the head of ecosystem and fundraising at Shardeum. By the way, this is the first hackathon we've sponsored in India, so congrats on being one of the first developers to build in the Shardeum ecosystem. Shardeum's an upcoming EVM-based layer one, co-founded by Nishal Shetty, the CEO of WazirX. We're focused on making decentralization affordable for everyone, no matter how many transactions there are. The biggest challenge in Web3 today has been that when your application becomes popular and you get too many transactions, blockchains get congested and gas fees start to rise. And global adoption of Web3 won't happen until this challenge is solved. Shardeum has solved it using an architecture called dynamic state sharding that allows us to increase our TPS capacity with each validator that's added to the network. So by scaling linearly, we can keep transactions fees low, no matter how many users there are. And this opens up new opportunities and use cases for you to build because now your applications aren't limited by scalability. A lot of the applications we have today in Web3 feel like novelty. They're built for a small number of users because of this rising gas fee challenge. Now on Shardeum, you have the opportunity to build using the Ethereum virtual machine with the same solidity, language, and contracts you've deployed before, and build new applications and use cases that aren't limited by scalability. So, please reach out to us if you have any questions. This is our DevRel Marcus Wentz here, who's going to take you through a few demos today. You should have the same experience building on Shardeum as you do on Ethereum or any other EVM-based chain. And following this hackathon, we'd love to continue to support you, introduce you to investors in our ecosystem, help promote the products you're building. We're hosting 5 to 10 meetups a month in different cities throughout India. We'd love to invite you to these meetups and help you present and build a community for your products. You can reach me on email. It's greg@shardeum.org. Thanks so much, guys. And Marcus, take it away.
Sounds good. Thank you, Greg, for the intro. Yeah, so
Absolutely.
I'll share my screen. So just one moment. Can everyone see my screen okay?
Yeah.
Okay, so yeah. So the structure of this is I'm going to kind of just go over like how to deploy on Shardeum and that through our docs, and also some examples of some smart contracts that are EVM compatible, and some other cool stuff that is coming up with Shardeum. I will also say that we're working on dark mode for our docs, so that's something to look forward to. I'm team dark mode, so yeah. So we recommend like if you're new to smart contract development to use Remix IDE, which I have open over here, which I'll show for demo, and you can visit it here. And basically, you have a bunch of contracts that will be here by default that are kind of like a template to work with. And here's an example contract, but I have another example that I'll show during the demo. And to quickly kind of like, this is like if you're learning for the first time how to use Remix, if you do Control S, this is how you can compile quickly without having to like go here and then compile. So that's the fast way to do that. Then deploying, you have a deploy button here. So you can pick between different networks. You have the virtual machine networks here, but you could also use MetaMask to use custom chains. Like you could use Ethereum mainnet or other networks like Shardeum and other testnets too. So let's see. Yeah, you'll get a transaction confirmation when you do deploy using MetaMask, but with the virtual machine, you won't really get a confirmation. Everything is like virtually instantaneous because you don't have to wait for the transaction to be mined in the mempool. So, but yeah, there's other frameworks like Hardhat and Truffle. Hardhat is good for if you have like a lot of different contracts where they use a lot of different libraries and you need to verify them. It's kind of hard to do that like manually on Etherscan or other block explorers, because then you'd have to put in like all these different libraries in, and it gets very kind of like complicated. So it's better to just use like verify and hard hat to do that. Truffle is like a kind of like a legacy standard for deploying as well. But yeah, so here's an interesting doc I want to share before I go into the Remix demo. It's a way to actually deploy the same contract cross chain. So the easiest way to do this is to just use the same wallet, use a fresh wallet that will have the nonce 0, or you kind of track the nonces. But just be careful when you're using the same wallet over and over to do that, because if one of them is off and you try to do them at the same time, it's like an automated script, it'll mess up the address. So yeah, a little bit more on how contracts are deployed deterministically is there's two ways we can deploy contracts. There's two opcodes for it. There's create and there's create two. So create is like the legacy standard for deploying contracts. It's based off of basically who is the address deploying the contract and the nonce, right? And yeah, so create two is a bit, it's newer. It came out in EIP 1014, which I believe is run by Vitalik himself. And yeah, so it's dependent on the contract or the address that's deploying it. It's typically a contract because you can't really call create two from what I've seen. You have to kind of have an instance of it through a contract. Assault, which you can put in, and the bytecode, which is basically like the unique code that comes with a contract where when you basically compile it, it'll tell you what the bytecode is. But the bytecode can actually deviate if you have a constructor argument. Then it would actually, that value that you put in for the constructor, let's say that you have like a custom address you want to put in or a custom number or something like that as a memory variable, and then you record that in the contract, that will modify this. So for this example, for one of the examples I showed where there's no constructor input to keep it simple, but there's another not as general purpose example where the input is not used, but it can be repurposed if you just hard code in the constructor values. It really depends on how you want to kind of approach it. Even though it is possible to also write it with that, it's just to keep it simple, not having to handle that change. So here's a interesting concept, right? So some people have asked, like, is it possible to deploy a contract with the same address? And the answer is actually yes, but it's very specific, right? So I think there was an issue where, so this is another scenario, but I think someone accidentally posted, they sent ETH to like a contract that wasn't deployed yet at a certain address, and then a person deploy the contract with a certain wallet, and then that nonce wasn't used. So I think they were able to retrieve those funds. So that's one way to do it, but that's assuming that it's like cross chain, right? So we're going to assume on the same chain, can we deploy to the same address? So for the most part, no, but here's an interesting way to actually do this in a very specific example. You won't see this often, but basically you'd have to have a contract that will be able to self-destruct, meaning that it'll be able to wipe all of its data and send all of its ether somewhere when it does self-destruct, so it doesn't just like burn that ETH somewhere. So we have a contract that is self-destruct, and then we deploy that contract using create two factory, and then basically we'd have to, after that contract's deployed with the salt and the same address for the factory, then we'd have to self-destruct that contract before trying to redeploy that contract with the same salt and bytecode. Otherwise, you'll get a revert error saying, hey, there's a contract with data here already. That data size is not 0. I'm going to have to revert because I don't want to overwrite that data. But when we self-destruct, all that data is removed. It's 0, right? There's no data at all. So it's like, oh, hey, you won't see this error anymore, basically, once you self-destruct. So I have an actual example of this on Etherscan. So this is a regular self-destruct contract that was not brought back. It was just self-destructed. Here's an example where it's a create two factory. I have this in the doc as well, the code for this, which is able to basically like deploy contracts with the same salt and bytecode. And here's an example of a contract that was deployed. It was self-destructed, and then it was redeployed using that create two contract over here. So I think it's a cool demo. But so going back to there's two different create two factories. So there's two types. You're gonna have the one where it's generic and you have the constructors hard coded in, which is very simple. And again, you could try to rewrite this to have the constructor creation code be dynamic, but again, I'm going to keep it simple. I assume that it's hard coded in, kind of like this. So I have the owner here, hard coded in. And I think for this one, this is a kind of like a general purpose one. This will actually inherit this contract here, and it'll know like based off of like its input args, it'll like be able to actually create that creation code for the bytecode based off of that. But it's not general purpose, so it would be like a one-time thing. So it wouldn't be as gas efficient, but it's a very kind of safe and easy way to do it. Okay, so what I'll do now is I'll do a demo on how to deploy to Shardeum. So I'm going to hit deploy. So I'll see MetaMask pop up, and be asked to pay gas in the form of SHM. Had to wait for the transaction to be mined, and it was mined. Okay. I think I have an outdated block explorer in my MetaMask, but I have it set up somewhere else. But anyway, we have that deployed. And okay, so the initial state, so this is basically just like a state contract where I have this storage slot. It's a uint, so it takes up a whole 32 byte slot in the EVM, this contract, and can emit an event after it changes the state. So we have a memory variable here, which gets recorded into storage, and it's public, so it's easy to access. So I'm going to record instead of, it'd be boring to just do 0 because we wouldn't be able to see really a difference. So I'm going to pick 1, anything that's on 0, just to change it up, so that the state is able to be changed. Okay. So send that transaction. So I'm actually going to go to the docs to find that. Yeah, so value is 1 for that. Okay, good. So change the state. Go to network points. Yeah, so the block explorer here. So this is the block explorer that we would use. So I'm going to just take my address to find my transactions, the last two. Okay. Oh, sorry, this is 2.0, not 1.0. We're using 1.0 right now. So that's the RPC URL. Okay. Here's the Explorer for 1.0. So 1.0 is not sharded, but 2.0 is sharded. Okay, good. Now we see the transactions. So success. And we can see here's the contract creation as expected. So yeah, you can see all the data here. Okay. So I'm going to close out the 1.0 example, and now I'm going to go to, actually, before we do this new demo, I'm going to explain this token, the ERC1155 token. So this is not as popular as the ERC20, which is like a fungible token for like a lot of like ICOs. And like NFTs are very popular for like big projects like CryptoPunks and 48 Yacht Club. So they're unique based off of token ID. But this token standard it's interesting. You can actually create both of these contracts in a sense. Like you can have tokens that share the same balance, like kind of globally, or you can have them just be one of one, making them as non-fungible because there's only one type of each. So yeah, like an analogy that I use is like basically like a NFT is like it's a brand of like a water bottle, so to speak. You have all these different like brands inside that vending machine, like one type of slot. But then with this token, the 1155 token, you can have all these different brands as well, so to speak. They're not tied to just one contract type. So you could also easily do like a bunch of different token transfers as well. So here's like an example of like having one of one. Actually, no, this actually has, these are fungible because it's not one of one, but these are more like ERC20 tokens because you can break them up into different amounts. Okay, so here's a demo of kind of like a contract that is basically meant to be spam. It's basically just going to mint a token where connect on my mask. I'm on a different network, 1.5. I'm going to go to 2.0. And I'm going to see, so I'd have to get 4. So like if I'm matching, so the idea of this is like we're basically trying to compete to see who's minted the most amount of spam, who's like spamming this contract the most. So 3 is the target right now. That's the highest one. But if we hit 3 as well, it won't update the state for the address. So we have to surpass 3. So if we hit 4, then it should change the value. Okay, so I'm gonna wait for the approval for this. Okay, so I'm gonna go to the Shardeum Explorer, and yeah, looks like it went through. Okay, that was 5. Now we have 6 total. And again, this is based off of the ERC 1155 contract. And as expected, the address changed. So this is our wallet address, and it's the new leader because we're spamming the most. We went from 3 to 4. So yeah, I'll briefly talk about ERC20 tokens for a little bit. So they're, like I said, they're basically like fungible tokens that are very popular for kind of like DAOs and just crowdfunding as well for projects. And we recommend you use Open Zeppelin as a standard for kind of making sure that you're following the specification for the ERC20 token. Those interfaces for those contracts are built in, and actually I have a doc on the interfaces that I'll jump to in a bit. And 721, again, one of one type tokens for the same contract. So yeah, here we're using, I think at the bottom, a ENS library for like measuring the length of the string as well for the NFT. So okay, so this talk is more about kind of differentiating between Liberty 1.5 and 2.0. So 1.5, like I said, is not sharded, so it's pretty easy to deploy. Like from a solidity standpoint, 1.5 and 2.0 are identical, assuming that the addresses are like the same with everything deployed, which they may not be. But assuming you update those, the code should be the same between or in the contracts with the general logic. Just the addresses might deviate a little bit. But from like a front end development perspective, or like if you're running like a bot for a backend service, it does change a bit because the idea is that on Liberty 2.0, the contracts they live on different shards, right? So unless they have the same prefix, think of it as like being on the same like block, so to speak. If they like live on the same block number, it's like, oh, I don't have to like go to another shard. I'm on the same shard, right? So 1.5 is one shard. 2.0 has all these different shards that have to cross shard communicate. So we use EIP 2930, which is a way to actually build in a way to not only pass in addresses that we're going to come in contact to with the addresses, but also the storage slots, so to speak. So like if we're going to, for that first contract that I showed in Remix with the storage slot, it was slot 0, so it would be like 0 here, and that would be the address for that. But it's optional for single contracts, so it wouldn't be mandatory to do that. But in certain scenarios, it would actually save gas to use this EIP as well. So it's a bit of a more challenging EIP to master, but there's benefits to it. So yeah, so if you're just transferring, again, basic stuff like transferring between wallets, you would not even know that it was sharded, the network. And if you're just dealing with this contract, you would have no idea. But this is where you have to be a bit more cautious, because what's happening here is that we're inheriting this contract here, and here, well, okay, we're making an object for it, not really inheriting it. We inherit up here more. Like we'd say multi-call is, but now we're just defining it here based off of an address. So yeah, so we have this object that's tied to this contract name, the object name, and when we do public, we could actually see the contract's address that's deployed. And we define it here. We're saying, okay, this object is this contract deployed at this address. So if you're gonna just try to call the data, like if I set the value from 0 to 1, I would see 1 here when I do this call, right? But for this, I'm actually sending a transaction, and I'd have to, assuming that they're on 2 different shards based off of prefixes, 2 different prefixes, this would be 2 calls. So it would be like from my wallet to this contract, but then this would also jump to this contract as well. So it's jumping to this, and then it would jump here for that. So it would be a multi-call that's cross-shard. So yeah, you'd also need to include the code hash as well in the access list. And we have an example down here with that here. So we have examples in Python and JavaScript for building that in like an automated way. This is just a Solidity example just to show how it would be done in Solidity, but there's libraries for using like ethers, RPC calls. Yeah. So naturally, you will need to kind of use EIP 2930 if you're going to use Solidity interfaces, because generally with interfaces, you're making basically like an abstract function for some type of other contract, and it could be based off of different Solidity versions, so to speak. So that's kind of how you can work with like old contracts, like wrapped SHM or wrapped ETH in either case. So wrapped ETH is like Ethereum mainnet. Wrapped SHM is like Shardeum, because that's the intrinsic token of the Shardeum blockchain. So basically, you trade in your message.value in the EVM for a ERC20 instance, and that's how you would convert between the two. Yeah, so here's an example of what the wrapped token would look like. So the idea is like you would have a payable function where you give up your the intrinsic like gas message.value currency on the chain, and then you would receive like an increment of that ERC20 balance. And then basically you'd have to withdrawal, you'd have to approve and then call withdrawal, so to speak. And be careful when sending tokens to contracts if you're not on a testnet. If you're on a testnet, it's like it's whatever, it's not that big of a deal if you just mint them again. But there have been scenarios where people, I think someone sent like ETH, I think one time to like one of these type of contracts, and they got the wrapped token back because there's a fallback function like this, or payable function, because this is an old Solidity version. So fallback and receive came later on in Solidity. But if you send ERC20 tokens to this, there would be no like recursive call to see like, oh, okay, like I received those tokens. ERC20s don't have that. So if you send tokens to an address, and you're not an owner to that contract, or like you're not an expert on how that contract works with like withdrawing those funds with it tracking your balance, there's a very good chance you will lose those tokens forever. So be very careful with that. So here's an example of an interface, right? So the interface is basically like, it's a way of saying like, hey, like we know that there's a contract out there that has all this like information tied into it, but we don't really care too much of like what it actually looks like. Like we know what it looks like. We're going to assume that we know all the details about the contract, but yeah, or the functionality, assuming it's safe. And yeah, so we had the function, we would call the method name, and then we would pass in the appropriate types of inputs for the memory variables that would be needed as inputs. And then basically make sure that if it's like a virtual type or some type of function that returns something, would matches that too, just to be consistent. And yeah. So the purpose of this example is to basically deposit token and do like a multi-call, so to speak. So like if you were just interacting with this directly on Liberty 2.0, you wouldn't know that you're on 2.0. But if you're trying to interact with this, you'd have to kind of build that access list, right? Because you're jumping from this contract, you're doing a call to multi-call here, and then you're going to jump to this object that's defined at this address. So it's this address here, jumping to this address every time. So basically, we make this a payable function, so it accepts SHM or Ether, and then this is a way of us actually forwarding that message.value amount to that call in this other contract and deposit, because it depends on the message.value. So it's relative to whatever call is happening here. So this call is message.value, so we're going to just forward that value because it's going to be shared here. And then so the person calling this will be message.sender. So the context of this will be, oh, I'm going to give the tokens to this contract, but basically they'll just be sitting in limbo unless I send them back. So it's like, okay, this contract gets those tokens because it was the entity that directly interacted with that contract. And then after that, I will basically return it to the original message.sender here. And I would recommend to use message.sender to avoid transaction.origin because of the security risk with it. Number one, phishing. And I think two, I learned this recently, front running as well. You could actually be front run if you're trying to be the owner for a contract. Someone could try to deploy your contract for you, and they would actually be able to kind of bypass that from you. So same idea here, but basically you have to call approve, kind of like here when you're doing a transfer from, or when contracts taking tokens from, you have to first give consent. Otherwise, people will be able to just call your ERC tokens from you and drain your wallets, which would be bad. So we have the transfer from, and then so it's like, okay, I'm taking tokens from user for the person who's calling this, and then with those tokens, I'm going to basically forward those tokens and call the wrap SHM token. And then the result of this is that the contract will interact with wrap SHM. It's like, oh, you sent me the tokens, now I have to pay back the SHM, right? So I'll get back SHM, but again, it's just going to sit there. So to handle that, I transfer the token. So I have to make the message.sender, the person who's calling it, payable, and then I basically just transfer all the tokens that are available. So yeah, that's basically it for this example. I think the last thing I kind of wanted to go over was automating the RPC call. Sorry, not the RPC call, but automating the access list in EIP 2930, because it is a bit challenging to implement it and to kind of calculate all that. It's not so bad if you're doing like one call, but if you're doing more complicated stuff in DeFi where you're doing like, hey, I want to do a flash loan from this protocol. So like if I'm going to go to Aave, do a flash loan, and then go to like, I don't know, Uniswap or some other entity, assuming they're just like two contracts, like you'd have another contract that's doing those multi-calls that would be like, call that kind of like proxy contract that's like able to call those other contracts, then call Aave, and then call Uniswap or whatever contract you're going to call. So that'd be like multiple calls. So you'd have to calculate all that. But ideally, actually, no, not ideally. It's coming soon, actually. we're creating an RPC call to automate that. But otherwise, like if you're doing all these calls and if they're changing, like if it was like a DEX aggregator, it would be like kind of a nightmare trying to like kind of pre-calculate that yourself. So from a validator level, we're trying to pre-compute what that is. And these are just some contracts that I've tested myself using a RPC. So this RPC call will be available in, I think, 2.1, which should be coming in the near future. So yeah, we have a bunch of tests here. We have, I'm just testing the endpoint here, and then they deploy a contract. You can deploy it as well with the remix with the endpoint with an external connection. But I will say this, when you're connecting like that, I would recommend to be careful with the remix endpoint that you're using. If you're using HTTPS, but your endpoint is HTTP, it will not work. So you'd have to change the remix IDE URL to be HTTP as well, and then it should work. So that's something I kind of had trouble with at first, but once I figured that out, it should work pretty well. here I'm testing basically like doing a single call and then a multi-call here. And I'm kind of just, here I'm testing the ERC20 calls. So basically just doing like having another contract that will call the transfer tokens. So that's pretty critical to an AMM, for example. Like when you're dealing with an AMM, it has to like kind of do a bunch of transfers and transfer froms to handle the tokens that you're trying to send to the contract and to have those tokens sent back to you. So I test these individually, and then I have a test where I first call transfer from. So yeah, I'll kind of go through these first. But yeah, main idea, I take tokens from the user and then I give them right back just to see if it will work back to back. So yeah, this is just like, hey, can I send tokens on this RPC endpoint? Can I deploy a contract with this bytecode that I got from Remix IDE? It's a bytecode object. And make sure it has a 0x in front of it. I think this might not have the 0x by default, so make sure to add that. We're using ethers to help deploy this as well, that bytecode as shown here. And yeah, I think the ABI in this context is only needed if you have custom inputs for the constructor inputs. So that kind of plays into the creation code, but because we don't have any inputs in this example, the creation code is equal to the bytecode. Basically, it doesn't really deviate because there's no input. Here we're just, I think we're directly interacting with the contract, and this is the multi-call one where we do need the access list. And yeah, so this is for the access list RPC call. This is the most important part. So the idea is like we use ethers and we pass in the address in the ABI and then the signer through ethers. And yeah, so then we pass that unsigned transaction that we built here based off of the calls up from this contract. So we have, okay, so it's like, hey, I have this contract that I have defined. And now based off of this contract instance that I have here, I'm going to create a transaction and call this, which is basically like, hey, I want to set the value to another contract using multi-call, right? And have this input argument as well. And it'll build that transaction. And then all I need to do is I just need to pass that object, the predicted access list, into, actually no, I need to pass that unsigned transaction, which is built here, and then call ethers for an RPC call, which is this new RPC call that we're testing. Get access list and it'll generate it. And then for testing, I have that printed out, and yeah, it goes right here. So be sure to also have type 1 when sending the access list as well. I think type 2, so type 0 is legacy, type 1 I think is what the access list, and I think type 2 is when you use EIP 1559, but we are not using EIP 1559 on Shardeum. We're just using legacy transactions with the access list for the transaction architecture. And here we have just a different transactions for the ERC20 tokens. And it's also good to just like before you sign stuff for debugging to check, hey, do I have enough tokens if I'm going to do a transfer? If you don't, then that'll probably be why the transaction's failing. So it's good to have checks like that. Yeah. And for the balance, let me just double check. Yeah, so in this example, I have the balance of the signer, but then later on, I think I have the balance of the contract. So I'm like, okay, like I'm about to send the tokens to the contract. Do I have enough? And then I'm like, okay, after that, does the contract have enough tokens to return them? As shown here. And then I could send those tokens back from the contract to the user. So it's like 2 contracts and 1 baked in. Kind of the same idea here, I think. Yeah, so assuming the contract doesn't have the tokens, I have to transfer them first and then kind of give them back. But yeah, so to do this, actually no, for this one, we want to first, let's double check. Yeah, so we don't actually need to object the proof here. It's good to just have it, just get a sense of where we're at. But it's more appropriate after, I feel like, because we're changing the state, but it's good to know before too. So we check to see, okay, do we have enough tokens? And then once we have enough tokens, can we consent to giving them to another entity using transfer from? That's the idea of allowance. So we have to call that ERC token contract directly. You can't do a multi-call for it for security purposes, for safety. How the ERC20 specification works. And then we say, okay, I'm going to give consent for this person to have this many tokens. And this is in Ether, right? I think this is about like 1 token, but it's like 1 times 10 to the 18 way, which is the lowest unit for this 18 decimal places entity. So yeah. So then once that's approved and we have allowance, then we can call transfer from, and it should work. And then this is just a combination of both. It just, for this, we just approve, because what, again, the idea is like we take the tokens, we need to approve them first. We're checking the allowance and the balance. And once we have those tokens approved, then we can do the transfer from and do the transfer. So yeah, that's about what I have.
Great, man.
Thank you.
Okay. Thank you, Marcus, for the workshop.
Of course.
In a very short notice.
Of course, yeah. Are there is there like Q&A? I can answer some questions, or maybe I went over something quickly. I could try to answer anything quick, because there's a lot of technical stuff.
Actually, there was a question like they asked, like for the eligibility of the bounty, if they deploy their smart contract on Shardeum, it will be enough to win the Shardeum track, or do they want any other things to do?
Yeah, so I think for the bounties, as long as it's a unique project that I feel like people put thought into, I think it should probably qualify. But I would say, yeah, 1.5 is good. 2.0 is good as well, because the Shardeum is really moving toward the like 2.0 type of architecture. But since we don't have the RPC call, it's a little bit more challenging to develop on it. So yeah, so I would say just have fun and just